Hi there, you're in the lab with your mate JJ. Today is Electronics Project Day, and I have to say I'm really not sure what we're in for today, but I'll tell you about that in a second. First of all, while I think of it, my silly job title for today is Note Taker. Today I'm the Note Taker. So, yeah, I was walking home from the hardware store the other day, and I saw a bunch of rubbish dumped on the side of the road, and had a bit of a sticky beak, and I found this. It's not worth anything really. It's an old Sanyo digital clock radio. It doesn't. Oh yeah, the model number is RM6018. Um, so yeah, just dumped on the side of the road. I don't know if it works or what. It's a bit odd. The power cable has been cut off, so I'm not sure why they did that. But I thought that we could just pop this thing open and have a look inside it together. I don't really know what to expect in there, but I thought I might just clean it up and have a look in there and see what's to be seen. So that's what we're going to do. I don't know what to expect. I don't know how long the video will take. I don't know what we'll find in here. I am not an expert teardown dude, so I'm just getting started. So I'm doing this really just for practice. Want to have a look at something simple, and the clock radio is pretty simple, so we might be able to figure out a thing or two about how it works. So let's jump over the bench and have a look. We're on the bench, and I thought we might start with some sort of a clean. I don't know what we'll use for cleaning. I've got this stuff, it's just general purpose cleaner. I might use that. And before I do that, I might just spray my hands with a bit of the isopropyl and kill any germs from handling this thing. It's been out in the wild. I don't know where it's come from, so thought I might just put the nitrile gloves on for this one. I wonder if I can show you. Yeah, you can get a whole view of me here putting my gloves on. I just broke it. It's not the end. No problem. I've been reorganizing stuff here. I jiggled the 4K camera and the Unity thermal cam, and I got the thermal cam closer to the table so it can get a closer view, and I got the 4K camera further away from the table so it could get a wider view. And I also actually put in a whole bunch of zoom levels as well. I'll show you that in just a second once I've got this glove on. Yeah, so I've improved the camera situation here just a little bit. I also switched the 4K camera over for the welcome cam. So the welcome cam is now in 4K, which is really good. It looks heaps better. Yes, that's all well and good. Now, I was telling you about the zoom levels. So if we go here, this is just the normal view, but we can actually go in closer and closer. So I've got it all set up so that we can zoom in. And I think this is the default view here, and I managed to get up the back here. There was glare from my microscope, but I've fixed that now, so that's good. Now, I'm going to give this a once over. I need some sort of a cloth. I guess I'll just use a tissue. My mate Nanofix, he doesn't know me. I know him. He's great. He does all this like surface mount reballing and stuff, like really advanced soldering, and he fixes consoles for people like the Nintendo and so on. I'm hoping to get into a little bit of OG Xbox refurbishing myself. But anyway, he had a couple of videos out lately just talking about the equipment that he uses and the supplies that he orders. And look at that, that's pretty grimy. Yuck. Yeah, I'll see if I can dig up those videos from NanoFix and see if I can refer you to them. Oh, yucko, this is a real mess. I don't know if we're going to need to take these pads off, if there's screws behind them or not. I think maybe not, just because you can see so many other screws here. You can see screws everywhere. Can you see all the screw holes? They're everywhere. There. They're everywhere. Mm. All right, I'll tell you what, I am going to give this a further scrub, but I'm not going to take your time. I'll just put you in fast forward until this thing's clean. Just grab the old battery tester here. Might as well have a look and see what it has to say. Dead. Dead. Not any power at all, nothing. Wow. Might get a second opinion on that. That's quite fascinating. Let's try the old fluke here. Put him into voltage mode. What are we looking for? DC voltage. Let's put it down to millivolts. Let's see. A few hundred millivolts, that's all. Wow. Oh, look, it's no different to background radiation. All right. Well, I'll just put the battery in the battery thing. This is the battery thing, the e-waste. There's a shop up the road that takes this stuff off your hands, so I just keep it in this little box here. Actually, I haven't seen it. The bloke's name's David, and it's his computer store. But I haven't seen him lately. I'm a bit worried that he might be going out of business, or I don't know. I haven't seen him around for a while. I do like to pop in for a bit of a chin wag with David when I get the chance. Now, this is going to call for a screwdriver. So let's see what we've got. Actually, one of the screwdrivers here is getting a bit rusty. Look at that. Can you see the rust on that? Terrible. Anyway, see if we can get this open. Not sure what that crack was. Did you hear the crack? All right, so we got 6 screws here. Got a little magnetic tray for the screws. Okay. There we go. All right. Well, oh, yep, he just popped open. All right, there's a... Oh, dear me, that's glued. That's no good. Man, this thing is dirty. Dirty. All right, well, let's see if we can get this in some sort of... All right. Oh, there's a cockroach in there. Yucko. It's a live cockroach. Dear me. Alright, I'm gonna get that. I'll sort that out. Alright, well I got rid of the cockroach. I don't know if there's only one in there. I'm trying to get this speaker off. I'm not sure if it'll just pop out or... Let's look at the dust on that thing. Isn't that awful? It's a real mess. Something's stuck there, I don't know. Is it some sort of glue? Yeah, it is some sort of glue. Alright. Well, that's the speaker off. I'm just going to go outside with this for a bit, give it a dust. Actually, before I do that, I'm just going to take off the Alright, I'll be back in a sec. Alright, well I'm back. So I just gave this thing a bit of a dust at the back. So that was some glue holding that down there. I managed to rip off a bit of plastic that was glued a bit too tightly. Fair enough. Now, this hasn't been made to unplug. It says snooze diamond 8KS01. So do we think it's clock? Yeah, I see. All right, so this is the clock circuit. Okay, that's the clock circuit. And this is the radio. Look at all the little trim pots for the... Are they inductors? I'm not sure what those things are. I don't know anything about radios. I'm a real noob when it comes to radios. But we've got... oh, there we go. That's tuning there. Very good. And this is volume here. This must be on and off for the old radio. Okay. And this is the digital clock. Now, let's have a look at the power circuit. So obviously main voltage comes in here. This is power in here. It just comes straight across the transformer here, and then into the clock, and then it goes through these rectifiers here. That's 4 diodes. That looks like a full bridge rectifier. Okay, they haven't used the actual bridge rectifier thing. That they just made one out of diodes. So there should be power coming out of that. I'm not brave enough to power this with mains voltage. Am I a wimp? I don't know. And here, there we go. There's 9 volts coming in over there. That's interesting. Now, does this... How do we... Okay, that doesn't come out. So we'll have to undo it. It'd be cool if we could salvage the clock. I'm not real super interested in the radio, but if we could make the clock work, that could be fun, don't you think? Oh yeah, okay. Interesting. All right. Well, I'm going to time lapse it. I'm going to take the clock out, and I'm going to try powering the clock with DC voltage. So let's pull this circuit out of the case. So this, for the record, is blue, white, black, and red. I'm going to pull that out. I don't want to do any mains power stuff. I'll try and power this off the 9 volts. So I'm going to take that out now. All right, so I've soldered the power back in, and I thought I might just try. What we got here? Give me 1 second. I'll see if I can find an adapter. Actually, before I go looking for adapters, I do have a battery up the back here. So let's just plug the battery in and see what happens. No, nothing. All right, so the battery might keep time, but it doesn't drive the LEDs. Fair enough. So what we're going to have to do now is figure out where the power from the bridge rectifier comes in, and maybe we'll be able to power it ourselves. Okay, well, I'm going to have to think about it. All right, I'm back. What it did was I just had a look here at what the integrated circuit is, and I searched for it, and I found it. So it's called the LM8560, and it's basically a digital alarm clock in a chip. Obviously, there's some other passive devices around it. It looks like some transistor or something there as well. But we've got the pin out. So if we can power it, given that it drives the LEDs, we might be able to make it go. So this says the LM8560 is alarm-equipped digital clock IC with built-in driver capable of directly driving LED display equipment. As IC himself, the VDD pin for the LM8560 is graded to withstand a voltage of 15 volts. Features: single chip P-channel ED MOS LSI. That's a large scale integration. We learned that the other day. LED direct drive using time division, duplex configuration. Wide operating power supply voltage range. Built-in alarm function with 24-hour control. Supports changeover between 12-hour and 24-hour displays. Built-in battery backup CR oscillator. Uses 50 Hz or 60 Hz as standard frequency. Built-in automatic fast-forward function for hour and minute settings. Built-in sleep timer function, maximum intervals of 59 minutes or 1 hour 59 minutes. Built-in snooze function, supporting repeat use. Equipped with power failure display function. 900 Hz output for alarm tone. Functions: current time display, snooze alarm function, sleep timer function. Okay, applications, alarm clocks, and clock radios. Now here's the pin configurations. So there's VDD, pin 20. That's probably what we want, isn't it? I don't know. Tell me about VSS. What's VSS all about? I should know this. I'm just learning this stuff at the moment, so I don't know. I'm gonna go research that. I'll be back. All right, so it looks like VDD is the positive and VSS is the negative, and everything else should be built in. So let's see if we can figure out where those pins are. Oh, they've lifted one of the pins here. That's the pin 1, AM and 10 hours. I'm not sure what that is, but they didn't put that pin in. So, get down there. I wonder if we can get our little hook clips in there. I reckon we'll be able to get in for sure. All right. Well, we're going to need... I wonder if I've got... this will do. All right, so we're going to go 15 for... for negative, and then 15, 16, 17, 18, 19, 20. Yeah, 20. All right, so we're going to go 16, 17, 18, 19, 20. Oh, not doing real well. Just try and get that out of the way there a bit. And I'm tempted to take that out again. We don't need that. Anyway, so. I'll tell you what, I'll time lapse this. All right, what I've done is put the DuPont female cables into the power supply. I'm going to set the supply at 9 volts. Let's say we put it at 9 volts. Reset 9 and over voltage. So VSet over, and we'll make it 10. And how much juice are we going to allow it? Let's just say just go 1 amp. That's a fair bit of juice. It shouldn't chew that much. I'm not sure really what I should be using there. Hopefully we don't blow everything up. So on off. Okay, let's put that on again. Goes up to 9 volts. Very good. So we've got negative here. Now hopefully this will work. Yep, that's working. And then this one here, up. 15, 16, 17, 18, 19, 20. Let's get that on there. There we go. All right. Well, let's throw the power on and see what happens. Nothing. How disappointing. Oh, that's a bummer. I was expecting something. I really did think that'd work. All right, well, we'll turn it off. Let's have a closer read of the that's no good. It wants 50 or 60 hertz input on pin 25. That's not good. Ah. All right, I'm going to go away and have a read of this. I'll be back. All right. So I went fishing a bit more, and I found oh, what am I doing here? I found an actual data sheet from Sanyo, and this radio was branded Sanyo, so it looks like they made their own integrated circuit for their line of clock radios. I don't know about Unisonic Technologies, if they've just cloned it or bought the rights to it or what, I don't know. But there's extra pins here that I need to know about. There's 50 and 60 hertz input, so I'm not sure if it wants a sine wave coming in there. I'm not sure. And then there's a 50 hertz or 60 hertz select, so you actually have to choose whether you want a 50 hertz or 60 hertz supply. Of course, in Australia, our power lines are 50 hertz, which is different in the USA. I think in the States it's 60 hertz. And of course, our line voltage is nominally 230, but in practice more like 240. Whereas in the States, as I understand it, it's more like 120. Anyway, I'm going to call this the end of this video. I'm going to publish this. I'll throw you over the farewell cam and we'll wrap up. But this is not the end, my friends. This is just the beginning. Anyway, I'll throw you over the farewell cam and we'll wrap up. That's a wrap. Well, it's not quite a wrap, is it? I'm going to come back to this. What did we do today? We had a look inside our clock radio, which we found on the street, gave a bit of a clean, pulled it apart. There was very clearly a radio and a clock. It's got 3 wires come through to power the sleep function and the alarm function, I guess. So that radio, we might play around with that. This clock, the 9-volt battery is not enough to drive it. I connected in VDD at 9 volts and ground at VSS, but it didn't work. Looks like there's other pins that we're going to need to play around with. We did manage to find the data sheets. There's various information out there. This one from Sanyo looks particularly promising. So when we pick this project back up again, we're going to be looking at the data sheet and figuring out how to make that integrated circuit happy. Basically, it's going to need power. I don't know what we're going to do if we need a 50 hertz or a 60 hertz input. Maybe I could get the signal generator to deliver that, but I'm not sure how much power it needs. I just don't know. But I'm looking forward to doing it. I won't do it today. We'll just pop this in the box and we'll come back to it for part 2. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.